My name is Ed Lugo, and I'm coming to you from El Camino Community College. I'm also an automation engineer for the Northrop Grumman Corporation. I'm here today to talk to you about education in the aerospace industry. And the title of this presentation is Spice Up Your Technology Course with Modularized Content. In my role at the college, I also serve as a co-principal investigator on a National Science Foundation funded grant for the development of education for the aerospace industry. The educational content that we're developing is of a digital nature and is designed to be inserted into pre-existing courses. Our team is a national team made up of Butler Community College in Kansas, Purdue University out of Indiana, Oregon Institute of Technology, and of course we continue to work with the Society of Manufacturing Engineers. We begin by looking at the key issues affecting education today. There's fierce competition for market shares at this time. The role of educators to prepare students has vastly changed from what was there as little as 10 or 15 years ago. And the requirement for rapid education is becoming even more prominent to help ensure student success. In reviewing the industry, we look to California aerospace growth. Total jobs projected through 2014 exceed 180,000. Almost 4,000 new jobs, which include technicians, machinists, NC operators, and aircraft mechanics. There is optimism for the future. Marion Blakey, President and CEO of the Aerospace Industry Association, talked about the importance of the aerospace business to our economic engine. Over 2 million middle-class jobs, 30,000 suppliers from all 50 states. Total aerospace sales in 2010 rose in excess of $200 billion, a new record for the 7th straight year. She talks about the economic benefits, which include a $53 billion positive trade balance and $81 billion in exports. Jim McNerney, Chairman and CEO of the Boeing Company, talked about U.S. competitiveness and innovation in the changing global economy. He talked about 818,000 aerospace and defense workers, 80% of Boeing sales going international. When a Boeing 777 lands in India or China, it lands with about 4 million parts reflecting workmanship of some 11,000 medium and large suppliers, the vast majority of which are from the United States. There is national and global optimism for this. But Mr. McNerney had some concerns. He talks about the government regulatory policies, the trade policies that affect our ability to meet the needs of our customers, the shrinking pool of skilled labor forced by retirement, the aging workforce. So he proposed some teaming strategies, part of which included private sector and working in conjunction with educational institutions, and continued support for STEM, science, technology, engineering, and math. So the team developed a simple survey administered to two-year technicians and manufacturing engineers, along with instructors, supervisors, and managers. And we focused on what key technical skills were needed and what key non-technical skills were needed to ensure success. Summary answers are addressed in this chart. We see several aspects to the survey results, including what was significant to new employees. The most valuable skills included common sense. From the instructor-manager perspective, it was hands-on. On the extreme side, question 18 identifies the least valuable courses, and from the technician's perspective, calculus rung high in terms of the least valuable courses, and history and philosophy from the standpoint of instructors and managers. Basic key technical skills requiring mechanical knowledge or general engineering knowledge were prevalent, along with key non-technical skills being the people skills or the interpersonal skills required to maintain clear lines of communication. We also asked if there was orientation, training, or mentoring available for these technicians. Most companies do offer some level of training, mentoring, and of course a lot of that is developed in-house. When we graph the data, we see that over 35% of the technicians and over 40% of the instructors managers felt that manufacturing skills in general were important to success. As we look at the data though, it suggests a number of other technical skills that are required, an awareness of math concepts and of understanding a process, along with some basic engineering and of course basic computer skills. Although if we look at the data, the technicians felt that the computer skills were most important or significant to their success, whereas instructors managers felt somewhat different to that. On the far side, if we look at QA and SPC, important again for instructors and managers, but not as important for that 2-year technician. And that follows suit with Six Sigma concepts. The data resulted in the development of this key technical skills pyramid. At the bottom, we look at the basic requirements for success, including some awareness of sheet metal, drilling and fastening, a basic awareness of composites, blueprint reading, drafting, and NC machining. Moving up the rungs, we look at an awareness of quality, CAD/CAM systems, tooling, assembly, and lean operations as being part of that 2-year program. Moving forward and overlapping between the 2-year and 4-year programs, we see design, Six Sigma, ISO 9000 awareness, and awareness of GD&T as being important, and then moving more towards a 4-year program in the intermediate rung. We look at statistical process control, mechanical engineering, and some awareness of stress. Moving up into the advanced arena, we have an awareness of materials and the ability to function on proposal teams as being important, that all leading up to advanced manufacturing. Moving into the key non-technical skills gap analysis, we see the significance of people skills playing a major role in ensuring success. Along the sides, you also see that some awareness of management is required. From the lean perspective, there was little from the technician's perspective, but very significant to instructors and managers. Also planning, some awareness of planning is important. Computer skills, although significant to technicians, were not as significant to instructors and managers, and I believe that's changing as we move forward. Communications, though, absolutely essential, not as much from the technician's perspective, but extremely important from the standpoint of instructors managers. Moving forward into the key non-technical skills pyramid of success, we look along the base and we see that a good attitude, ability to listen, some awareness of Microsoft Office, shop coordination, being open-minded, and having confidence as being key to ensuring success. Moving up the rungs, we see from a basic platform, understanding the planning functions, having the ability for critical thought, some awareness of lean manufacturing. Strong is the ability to build trust, and of course, some ability for technical writing. Moving into the intermediate arena, we see that an understanding of ethics, cost control and estimating, some presentation skills, and time management as being essential. Up the rungs again, there's the people skills, conflict resolution as being important, and of course some awareness of the QA tools that are available. Moving into the advanced rung, we see that risk management and project management are key to enable someone to move into the realm of business leadership. We cannot get anywhere near success without the appropriate level of collaboration between both the industry and education. So we look to corporate sponsorships, common mentoring goals, and the use of affordability projects to increase student and intern participation. We must stay relevant, and we must leverage existing programs for rapid responses to the needs of industry. A key component of that vision for the future is to make education relevant. Alvin Toffler stated, school teachers are working from dated textbooks. They struggle to retain relevancy for students who are now Googling from cell phones. The rapid learning curve supports reduced implementation cycles. Change right now for us in this generation is exponential. This slide depicts the evolution of the telephone. It took over 100 years from the development of the telephone to the ability for us to have a mobile phone. From that standpoint, we look at the growth curve over the last 10 to 15 years in cell phone technology that has literally changed the landscape of how we perceive technology in this day and age. Can You Hear Me Now last year was a major advertising campaign. This year it is, Can You See Me Now? So I quote back to my CEO from Northrop Grumman Corporation. Speaking as an engineer, for many critical skills, there is no substitute for actually building something. If we don't have new projects, those skills will atrophy. So we move into another phase of our grant period, in which we look at the opportunity to develop a low-cost kit that can be used as a lab for new technologies being developed. These low-cost kits are off the shelf. The content of those kits, the labs that are associated with those kits are developed by our NSF team. These kits are currently being tested out at Butler Community College and at Oregon Institute of Technology. That concludes this part of the presentation. Thank you and good luck.